Welcome protein coders, let's build some coding muscles. Today we're going to solve a problem, maximum alternating subsequence sum. It's available on Leetcode, problem number 1911. This problem is very similar to the maximum subsequence sum, just a little bit of variation. So let's see what problem says. So we are given an array and we can form multiple subsequence from this array, right? And every subsequence will have their own indices. And in each subsequence, we have to calculate the difference between the sum of the elements at the even indices minus sum of elements at the odd indices. And at the end, we have to return the maximum possible difference for all the subsequence cases. Okay. So let's take this example and build the intuition. At first, my pointer will be at index 0. Okay. So I can either pick this element or I can skip this element. If I pick this element, it will be at 0th index. So it will be positive in my answer in this path. Okay. So now I have 2, 5, 3 on both sides to choose. Okay. So I can either pick 2 or I can skip 2. Okay. If I pick 2, this time the 2 will be landed on the index 1. So it will be negative. Okay, and if I skip, it will remain plus 4 only. Okay, I am just drawing for a single path. Okay, you will get the idea from here. Again, if I pick and skip, so 5 will come at index 1. So again it will be positive, right? So if you observe the pattern, whenever I am picking the elements, the parity of the element in that path changes. Okay. What I said is, whenever I am picking an element, the parity of the element in that path changes. Okay. See, when we are skipping, so the 2 will come at index 0. So whenever I am skipping, the parity remains same. So when I second time skipped, and I chose 5, then 5 will again come at index 0. So the parity of 5 remains same. Okay. So whenever I am skipping, the parity remains same in the path, sum path. So I can take two variables, idx for index and is even to track the parity. Whenever I am picking, the parity changes. Initially it is 1, that means it is at even parity. And whenever I am picking, it's changing. So let's write the recursive code for this. So let's write our solve function. It will take index is even and nums vector. Whenever index reaches out of the bound, we will return 0, or else we will get first the value at that index of nums. It will depend on the parity. If it's even, then we'll take positive. If it's odd, then we will take negative of it. First case is skipping. So if we skip, we'll simply call solve and increase the index. Else, if we are picking, then we will increase the index as well as change the parity and add the value. And at the end, we will return the maximum of skip and pick. That's all. Right? First, we will get the value. We have two cases, skip and pick. Skip, we will just increase the index. Pick, we will add the value and reverse the parity. Let's write it down on the code. Let's return our solve function, which will take index is even and nums. Let's define our solve function. Base case will be if idx return nums.size, return 0, or else we will get the value. And our two cases, skip and pick. In pick, we will inverse the parity and add the value, and then we will return the maximum of skip and pick. And we have passed all the example test cases, and yes, we got the TLE because it's a simple recursive code. Now we have to memorize it. If you observe carefully, index value can go from 0 to n-1 and is even can go from 0 to 1. So we have two variables here. Okay, for every index we have either it is even or it can be odd index, right? So for every index we have two possibilities. So we need to create a 2D DP vector. Okay, so let's get the size and create a DP vector, okay, of size 2 into n plus 1. N plus 1 is just to handle any out of bound cases. So let's pass our DP vector everywhere, and in our function calls also. At the end we will store the value in our DP vector, right, storing value, and we will also insert a check. If dp of is even idx is not equals to -1, we will return dp of is even idx, and that's it. Let's quickly submit this. We have passed example test cases and we have passed all the test cases. Congratulations. Okay, now let's see the tabulation code. For tabulation, we know for every idx we have is even 0 or 1. Okay, and in our memoization code we have moved from index 0 to n-1. So in a tabulation, because it's bottoms up, so we will move in reverse direction, right? So we will have two for loops, one for index from n-1 to 0, and for every index we have two is even condition, right, 0 and 1. So another for loop for this, and I just directly copied the recursive relation from above, and wherever there is a function call I just wrote dp instead of that. Okay, just like we did in our earlier questions. And if you see at the end, when index becomes 0, in our example also we have started from the even parity. Okay, so we will return dp of 0 1, where 0 is the index and is even is true. Now let's code this up. Let's get the size and the 2D vector dp. Okay, let's write our for loops. Index from n-1 to 0 and is even from 0 to 1. Now according to our recursive relation, let's get the value first. If it is even, then num's index will be positive or else negative. First case is skip, other is pick, as it is copied from the recursive relation, right? At the end dp of idx is even equals to max of skip and pick. At the end we will return dp of 1, 0, 1. Index is 0 and is even is true. Let's quickly run this. Yeah, we have passed example test cases. Let's submit this, and congratulations, we have passed all the test cases. Okay, now you are wondering how we're gonna space optimize this, right? Let's see. Let's say this is our dp vector. Okay, and for index n both will be values will be 0, and let's calculate this case when is even is 1. Okay, so the value will be the positive of nums of index. Now if I calculate the dp at this value, what this will be, let's call it next even. Then it will be, for skip case it will be next even, comma, let's call it next odd. It will be next odd plus value. Okay, and if I calculate for the is even equals to 0, that means for odd index the value becomes the negative of nums index, right? And because the parity changes, so next even and next odd will change, and that's it. In this case the dp at that index comma is even is maximum of next odd comma next even minus value. That means our values at index idx, they are only dependent on idx plus 1 values. Okay, next even and next odd. So let's quickly remove our dp vector. Okay, now let's define the next even and next odd. Both will be 0 because they are at index n initially. Now the current even will be maximum of next even comma next odd plus value. Similarly we will write for current odd. And if you see, after calculating them, okay, we will move backward, right? We will shift current ones and we will shift next odd and next even also backward. So next even will become current even and next odd will become current odd. That's it. At the end, what we will return? When index becomes 0, we will return the next even, right? So at the end our next even will be the answer. Okay, what's the error? Okay, my bad, I don't need to calculate value like this. I can simply add num psi and subtract num psi. Now let's quickly submit this and see. Yeah, we have passed all the test cases. And indeed our space optimized solution got submitted. Now let's discuss about the time complexity. For recursion, we are choosing pick and non-pick, right? For every case we have two options. So it will be of order of 2 to the power n, which is exponential, very high. Therefore we used memoization. We filled a dp vector, order will be order of n. For tabulation also we have a dp vector and we have two for loops, but the other one is constant, right? 0 to 1. So it will be order of 2 times n, which is again approximately equals to order of n. And for space optimized approach, again we have a for loop from n minus 1 to 0. So time complexity will be order of n, but space complexity will be constant. Okay, so that's all from my side, guys. You will find the problem and the complete solution link into the description box. If you have any queries, please mention them into the comment box. I hope this helps. Let's meet in some other video. Till then, keep smiling, keep practicing. Thank you.